Now let us start with the new topic, rational and irrational numbers. Before we start with this chapter, let us discuss few concepts. Although we've already done, but let us discuss these definitions. First of all is natural numbers. The counting numbers are known as the natural numbers. For example, 1, 2, 3, 4 and so on. Whole numbers. All the counting numbers including 0, they are whole numbers. For example, 0, 1, 2, 3 and so on. Now integers. All the whole numbers and the negative of all the counting numbers. That means minus 3, minus 2, minus 1, 0, 1, 2, 3. All these numbers, they are integers. Next one is fractions. The numbers of the form a upon b, where a and b are the natural numbers, they are fractions. Now examples for the fractions are like 14 upon 5, 16 upon 213, etc. and so on. Next is terminating numbers. Terminating numbers are those numbers which ones, if we divide, like 1 by 4 is there. If I divide this number, the quotient which I get, that is a terminating number, terminating decimal number. 3 upon 8, if I divide this number, I will get 0.375. So this is a terminating number. Next comes repeating decimals. As by word, it is clear. A decimal in which a digit or a set of digits repeats continually is called either repeating, recurring or periodic decimals. For example, like 1 over 3 is there, and if I divide this number, I will get 0.333 and so on. This number will keep on going and I will get this number. Now, the way to write this, notation to write the repeating decimal, let's say if 2 over 3 is there, and after dividing I am getting 0.666 so on. I can write this as 0.6 bar, or 2 over 3 can be written as 0.6 dot. Either you can write this dot or you can write this bar to represent recurring decimal numbers. Now decimal fractions. A fraction whose denominator is 10 or a power of 10. That means either it can be 10 or exponential power of 10. That will be the decimal fraction. For example, 7 upon 100, 37 upon 1000. The denominators are in the powers of 10 and so on. Now we'll move to vulgar fractions. A fraction whose denominator cannot be expressed as the power of 10. So this is the other way we have discussed the earlier definition. Like 22 upon 73, 199 upon 400, 63 upon 125 and so on. Now in order to check whether a number can be a terminating fraction or a decimal form, I just need to see the denominator. Let's say, let me take number 2 upon 50. I know I can reduce this number. This will become 1 upon 25. Now 1 upon 25. Now if the denominator can be written as the exponential power of 2 or exponential power of 5, or I can say product of exponential power of 2 and 5, then the number will be terminating decimal numbers. Okay, I use this concept here in the given question. 1 upon 25. This can be written as 1 upon 5 square. Now denominator is in the exponential power of 5. So without dividing, okay, by just looking at then factorizing the denominator, I can check this number will be a terminating decimal expansion. Now let us discuss few questions from exercise 1A. Without actual division, find the fractions are terminating decimals or not. As I've just discussed, now what we'll do, we'll check. This is 9 upon 25. 25 can be written as 5 square. Now because denominator is written in the exponential power of 5, so therefore it will be a terminating decimal. Okay, let's take next example, 13 upon 16. 16, that means 4 square, or I can write 13 upon This will be 2 raised to power 4. Even here, denominator is in the exponential power of 2. So without dividing, I can say this number will be terminating decimal. Next one, 9 upon 50. Okay, 9 upon 50. 5 into 10. Or I can say this can be written as 5 into 2 into 5. Or in the exponential form, 2. Exponential power of 2 is 1 here. And for 5 it is 2. Now this number, the denominator is written in the exponential power of 2 and 5. Again, this number will be terminating decimal. Okay, let us discuss more questions here. Question number 2. Convert each of the following decimals into a vulgar fraction in its lowest form. Now 0.65 is given. That can be written as 65 upon 100. If I reduce it to simplest form, I can see this number can be cancelled by 5. So it will be 13 upon 20. Now this number cannot be further divided. So this is the number, decimal number into vulgar fraction. Next one, third question. Convert each of the following fractions into decimal. Let's take example of 1 upon 8. And I just want to convert it into decimal form. Of course, numerator 1 is smaller than the denominator. I will take 0 here and the quotient will start by putting decimal. If I divide it, you can see after dividing, I can have 1 over 8 can be written as 0.125. So this is how we can convert fractions into decimal form. Okay, now question number 5. Express 13 upon 34 as a decimal correct to 3 decimal places. Now as I can see 34 in the denominator, of course this number is not terminating decimal, then I will be just dividing and checking out this number up till 3 decimal places. Okay, let's see. After dividing, when I divide, like 13 obviously is less than 34, so I have to start the quotient by putting decimal there. So 0.38203. Because I need to find the answer up till 3 decimal places, I will be dividing up till 4 decimal places. If you can see at the 4th place here, 0 is there. That means I cannot round it off. So eventually the answer will come out to be 13 upon 34 is equals to 0.382. Next one, let's discuss question number 7. Okay, this one is important. So express the following as a vulgar fraction in the simplest form. Now I'm given here, these are recurring digits, recurring decimals here. So if I need to write them in the vulgar fraction, I will let them as P over Q. Let them this be a fraction or a rational number here. Now this is equals to 0.5 bar. Now if I multiply this 0.5 bar, when I multiply by 10, 0.5 bar means 0.555 so on, multiply by 10. When you multiply this number, this decimal number by 10, you will get 5.555 so on. That's why after multiplying, I can write this as 5.5 bar. So what I've done, I've let P over Q is equals to 0.5 bar. Then multiplying 1 by 10. Of course, I'm multiplying equation. So left hand side will be 10 P over Q and this will be 5.5 bar. If I need to convert it into fraction, I need to see this digit. It should be cancelled. And when you subtract both these equations, you can see on the right hand side, I will get 5.5 bar minus 0.5 bar. So if I try to subtract, it will be 5.5 bar, 0.5 bar. Of course, this will be cancelled and I am left with 5. That's why on the left hand side, automatically I have got 9 P over Q, which is equals to 5. And this implies P over Q is equals to 5 over 9. So this is how I convert a recurring decimal into a vulgar fraction. Let's take few more examples here. Now I'm taking 4.17 whole bar. Now the digits which are recurring are 1 and 7. That means the number will be like this: 1 7 1 7 1 7 1 7, so on. So instead of writing this again and again, we put bar here. Again I have to convert it into vulgar fraction. I will let P over Q is equals to 4.17 whole bar and name this as equation number 1. Now since two digits are there, therefore I will be multiplying this with 100. When I multiply this with 100, I will get 417.171717, so on. That means I can write 100 P over Q is equals to 417.17 whole bar. This is equation number 2. Now subtracting 1 from 2, because here you can see after decimal, immediately after decimal, the digits which are given, they are having bar on them. Here also, immediately after decimal, the digits are having bar on them. So this can be cancelled out. Here, if I subtract, I will get 100 minus 100 P over Q minus 1 P over Q, 417.17 bar minus 4.17 bar. Solving, I will get 99 P over Q is equals to 413, and this implies P over Q can be written as 413 upon 99. I will take one more example. Now here if you'll see, this is 0.136 and bar is on 36 only. Bar is not on 1. What I will do, I will let P over Q is equals to 0.136 bar. This is as first equation. Now if I want to cut it out or further solve it, what I will do, I will take this one to the other side. That means I will multiply first equation by 10. After multiplying first equation by 10, I will get 10 P over Q is equals to 1.36 whole bar. Now if you see after decimal, I got two digits which are having bar on them. Now I will start simplifying from this step. I will multiply this equation number 2 by 100 because two digits are there. So multiplying second by 100, what do I get? 10 into 100, 1000 P over Q is equals to 136.36 bar. Okay, if I try to subtract this from equation number 1, you can see here the digit with the bar is not there. But in equation number 2 and 3, you can see the digits, they are immediately, the digits which are immediately after decimal, they are having bar on them. So this will be easy for me to subtract. So I will subtract 2 from 3. That is 1000 P over Q minus 10 P over Q is 136.36 bar minus 1.36 bar. I get 990 P over Q is equals to 135. Because 135 upon 990 can be simplified further, so I've converted this into simplest possible form. That is P over Q is equals to 3 upon 22. Now based on this, you have few questions from exercise 1A, so kindly try those questions. Now we'll continue with rational numbers. You have done up till fractions here. Now rational numbers are the numbers, of course, which can be written in the form of P over Q, where Q is non-zero. P and Q are integers. And one important condition is that the HCF of P and Q should be 1. So we have to be very careful. Otherwise, they will be fractions. Now, a few different type of questions in 1B. They are quite easy, but let us quickly discuss. Write the additive inverse of minus 3 over 17. Of course, if I see additive inverse of 3 over 17 will be, minus 3 over 17 will be plus 3 over 17. What about 0? Of course, it will be minus 0. Now, next one. Second question. Write the multiplicative inverse of 5 1 by 4. First of all, I'll convert it into fraction. Let's see, this is 21 upon 4. Multiplicative inverse means I should be finding a number which when multiplied by 21 by 4, I should get 1 here. Of course, it is 4 upon 21. So 4 upon 21 is the multiplicative inverse. Minus 2 by 3. So minus 2 by 3, I need to find the number which when multiplied by this to get 1. That will be 3 by minus 2, or you can write minus 3 by 2. This will be cancelled and this is the inverse here. Now, next type is when I need to find the rational numbers between any two rational numbers. So I need to find, this is fifth question, third part. Find two rational numbers between 3/4 and 1/5. Okay, I will reduce this first, convert this 1/5, write into 6/5. Now I need to find two numbers between 3/4 and 6/5. The rule is, first of all, I need to see that the denominators are same or not. Here you can see denominators are not same. So I will make them same by taking LCM. That is, LCM of 4 and 5 is 20. Now here I need to make 20. That means I will be multiplying and dividing this number by 5. I will get 15/20. 6/5. I need to make denominator 20. Fraction should be multiplied by 4/4. Okay, this will be 24/20. I need to find any two numbers between 15/20 and 24/20. Denominators are same. I can just check through the numerator. 16/20, 17/20, or you can write any number between 15 to 24. That will be the rational numbers between 15/20 and 24/20. Okay, one more different type is there where we have to find, let's say this is question number 7. Find four rational numbers between 4 and 4.5. Kindly use this method. I will find variable d here, which is equal to, the formula is b minus a upon n plus 1, where a and b are the numbers in which I need to find, like I need to find the numbers between 4 and 4.5. In decimal form it is given. So I'll take this as a and this as b. N will be the numbers of rational numbers I need to find. So I got all the variables. I'll substitute it here. That is d is equals to 4.5 minus 4 divided by 4 plus 1. Now what I get? D is equals to 0.5 by 5. That is d is 0.1. I got d to be 0.1. Now required rational numbers. The method will be, I got the first term, that is 4 here. D I already got. So it will be, first number between these two rational numbers will be a plus d. Second will be a plus 2d, a plus 3d, a plus 4d. So I will substitute the values of a and d in the respective formulas and will get the required rational numbers. So students, based on these questions from exercise 1a and exercise 1b, kindly try, and we will take doubts in the next online session. Thank you.